Okay, this is the second video for solving exponential equations. This one's a little bit different because we're not going to have like bases. So there's got to be something else we can do. So I want to take you on this form so we can go down a little bit. I want to show you some notes that I gave you. Here they are. Okay, so here's exponential form. I know it's exponential form because I have this base to some power, this exponent here. This is log form. I know it's log form because it has the word log in it. It might also have ln, which is natural log, but most of the time you'll see log. So this is how I know if it's exponential or log form. They are inverses of each other, so I can write one in the form of the other. Just like cubic and cube root are inverses of each other, so they're related. Okay, so what I want you to notice is they have the same components with the exception of this word log. So my y is my same y. That's what I'm taking the log of. My b is my base in exponential. It's my base over here in log. It becomes little. And then my exponent over here in exponential, the x becomes what all of this equals. So you don't have to memorize this. You can even just keep referring to this, which is why I put it in, keep these in mind kind of notes. All right, so let's actually look at a problem. And I have it on here too. Notice it doesn't always have to be written in the same order. This x equals can be on this side because, one side can always equals the other. The order in which you write it doesn't matter. So I currently have exponential. So this is my exponential. Notice that my y is on this side. So don't let that kind of bother you. If that kind of freaks you out and you want to rewrite it so it makes more sense to you, you can rewrite it in that order. Those are the exact same thing. Literally, one side equals the other. Whichever one I say first doesn't matter. Okay, but for our purposes, if that helps you see that that's your y and 2 is your base and x is your exponent, then go ahead and rewrite it in that order. Okay, obviously they don't have like bases, so I can't just, set their exponents equal to each other. But what I can do is rewrite this in log form. So how do I know to use log? You're always going to use log unless it's an e, and that's a natural log, and I'll show you an example of that. So we write the word log. Whatever my base was, and in this case it's a 2, becomes my little baby base. And I take the log of my y. My y was 7. And all of that equals what my x was. And my x is still just x here. Okay, so all you did was convert from exponential to log form. Do you know how to, simplify log base 2 of 7? No, neither do I, which is why we go to Desmos. So we're going to go over to Desmos. And in order to type this, we want to go to Functions, Miscellaneous, and you see here this has a log and it has a little base A. So you see my cursor is where the base is. So I can type log base 2. I put the 7 in the parentheses. I can now simplify that. Now, Big Ideas has you simplifying it to the thousandths place. So that means I need 2.807. And I'm not rounding up because the number after the thousandths place is 3. That's not 5 or above. So my answer is 2.807. Okay, that was the first problem. So my x was already alone. I didn't have to do anything special. The first thing I had to do was convert it. And then I just put it in Desmos and I have x alone. That's my solution, done. And again, I rounded to the thousandths. That's 3 decimal places. Let's do example number 2. This time, we're still going to have to convert it because I'm not going to have like bases, but I'm not just going to have an x by itself. So here's my problem. 4 to the 3x power equals 36. And again, if that's confusing and you want the y to be on the left, that's totally fine. You can just rewrite it. And if that helps you see what these pieces are, that's totally fine. Okay, so this is my y, this is my base, this is what my exponent is. So again, I'm going to write the word log. My base is 4, so baby 4. and I'm taking the log of the y, and in this case that's 36, and all of that equals my exponent, 3x. Okay, again, I got to go back to Desmos because I can't do the log base 4 of 36 in my head, which I don't think anybody can do that. So go back to functions, go to miscellaneous, log base a. I'm going to type in that 4 is my base, and then of 36. So again, I'm rounding to the thousandths. So you can see here where my last number is a 4, but the number to the right of it is a 9. So 5 or above, give that number a shove. So my when I simplify it, it's actually 2.585. Now, if you recall, I didn't just have an x by itself. I had a 3x. So I haven't solved for x yet. This one takes one more step. So just like you normally would, try to get rid of this x, I'm just going to divide both sides by 3. And again, I'm not doing that in my head, so I'm going to go back to Desmos. And I can divide 2.585 divided by 3. Still rounding to the thousands. That's 3 decimal places. Okay, and the fourth one is 5 or above, so that 1 is going to round up. So my answer is 0.862. So a lot of these answers are going to be decimals. That's totally fine. Don't let that discourage you. Don't let you think that's wrong. It's not wrong. Okay, that was example 2. So this one was just straightforward. There was no step after you put it in Desmos. This one, after you put it in Desmos, you still had to solve for x. So let's do one with that natural log, your new friend. Natural log, that base e. Okay, so let's say my problem is e to the x plus 2 equals 12. All right, so this is my last problem. All right, obviously not like bases. Now, what's different about this one is that it's natural log. So natural log, instead of writing the word log and keeping that baby base, we don't write log base e, we just write ln. And I know that doesn't make sense. It seems like it should be nl because natural log, I don't know. Anyway, we're going to write ln instead of log base e. Okay, so let's go back here. And again, if it helps you to write the y on that side and put the base with the exponent on this side, go ahead and do that. I understand why that helps you see the conversion a little bit easier. So I'm going to write ln. So I'm not writing log base e, I'm writing ln instead. I'm still taking the log of the y. That was my 12. And what I equal is still the exponent. My exponent is x plus 2. Okay, so I don't know what the natural log of 12 is. So I'm going to go over to Desmos, and you can just type in with your keyboard ln, natural log 12. And you can see Desmos knows what we're talking about and knows I wanted natural log. So again, I'm rounding to the thousands. Oh, come back. 2.48. And if you notice, this last 4, the number to the right of it is a 9, so it's going to round up. So that's 2.485. And going back to my actual work here, that equals x plus 2. So I haven't solved for x yet. I'm going to do what I normally would do if this is like a normal number. I'm going to subtract 2 on both sides. So x equals, and these, so 2.485 minus 2 is just 0.485. That is my answer. That is my solution, and it's rounded to the thousands. So I cannot say this enough. I would go back to the reference that's on the notes, or I would look at this and write it down, somewhere on a paper so that you can refer to this as you do the practice problems. And then make sure you're using Desmos and you're rounding to the thousands. Thousands is 3 spots. Okay, and that's how we solve an exponential equation, by converting to log.